Hello and welcome in the CNN session. I'm Hanan Miftahi from Algeria, and today you're going to learn the basics of artificial intelligence, deep learning, artificial neural networks, convolutional neural networks, and last but not least, transfer learning. By the end of this session, we're gonna get hands-on coding. There's no prior knowledge required except for the last part, of course. Algorithms are all around us, from face recognition to recommendation systems like the one used in Netflix to search engines like Google. Before defining what's an algorithm, let's first define computing as a whole. The purpose of computing is to process information automatically, hence its name. It relies on machines capable of processing data thanks to algorithms. But what's an algorithm and how can an algorithm process data? An algorithm is much more like a cook recipe. It's a series of instructions that must be followed in a certain order. Let's say you want to make a piece of cake, right? So you would need ingredients and some steps to follow. Ingredients represent data, and those steps to represent our algorithm. Translate the algorithm into a language understandable by a computer and you'll have a program. Let's take a look at this program that adds two numbers and displays the results. So what do you notice? It's like we always have to tell machines exactly what to do. That's called traditional programming. In the 1950s, researchers began to dream. They were looking for a way that would make computers as intelligent as humans. In 1990, expert systems came into action, trying to reproduce the reasoning of a specialist as a doctor or a cook. But one drawback, we had to transmit the expert's knowledge into the machine, which was extremely disappointing since what they wanted was to build intelligent machines learning at their own. At the end of the 90s, there was known a big step forward in the AI arena. IBM's supercomputer, Deep Blue, defeats world chess champion Garry Kasparov. And in 2016, a Google algorithm beats one of the best players in the world of Go, when we didn't imagine that this would be possible for several years. What is artificial intelligence? To answer this question, we must define first biological intelligence. Along with AI are born the cognitive sciences, which study human intelligence. They have made it possible to identify the different mechanisms which are at work in the functioning of thought. This thought allows us to perceive, speak, move, or to be creative. To simulate human intelligence, the idea was to reproduce cognitive functions. To achieve this, the researchers favored two approaches that reflect our way of learning, either through the transmission of knowledge, example, expert systems, or experimentation using a numerical approach which is at the forefront of the scene today, using machine learning and artificial neural networks. All the artificial intelligences that we come across today are very specific. They can only do the task for which they were programmed and configured. The program that beats the world champion of Go cannot recognize a dog. On the other hand, for a precise task, they are ultra efficient. Deep learning is a subset of machine learning, and it relies on artificial neural networks. The artificial neural networks offer a method of calculation that draws inspiration from the brain. Biological neurons are cells connected to each other. When a neuron receives a signal, it can either not send it back or return the signal. Artificial neurons are mathematical functions that mimic how real neurons work, where dendrites represent input, the soma or cell body represent the node, the synapse represent the weights or inner connections, and the axon which represent the output. Each unit is going to calculate the sum of the weights multiplied by the inputs plus the bias. Each neuron combines its inputs and provides an output. To do complicated functions, if we associate lots of neurons, then we will get a deep neural network. This method is not new. It dates from the 1950s, but it requires considerable computing power and a mass of data.